We'll proceed in tedious calculus problems. Okay, so we are in a phase to solve tedious calculus problems, and we are in a kind of, in a way, in a mode to calculate the current and voltage equation of a resistor RC circuit. Okay, so what we try to say is, I have brought everything. This is a 3.7 volt battery, and it is written as 500 milliampere hour. As we have described, 500 milliampere hour means for 1 hour at 3.7 volt, it can transfer 500 milliampere current continuously. What is wattage of this? Wattage is current into voltage. Okay, that is for 1 hour. So it is for 1 hour. So 500 into 3.7, that much is the wattage. So 500 is 0.5, 500 milliampere. 500, I'm sorry, 500 milliampere hour. That is 0.5 ampere. Okay, 0.5 ampere into 3.7 volt. How much it will be? Around 2 watt. Okay, something is written here. 1.85 watt hour. So 3.7 into zero point 0.5, how much it will be? A kind of 538, 8.5, 1.85. So 1.85 watt hour is the power of this battery. This is a lithium ion battery. Okay, so if I see other thing, I have one capacitor. I have one capacitor, and it is 100 microfarad at 16 volts. So it is all right. I have another capacitor. Okay, this capacitor is 330 microfarad at 25 volt. So all right, I have taken two capacitor, not required. One is enough. So these are the kind of two capacitors, two capacitor, and then this is the lithium ion small battery. Okay, anyway, and now with the battery, I have soldered one resistance if it is visible. Okay, this is a resistor, this is a resistor, and this is 330 ohm, just 330 ohm, not even 1 kilo ohm. Okay, the idea behind this is I have one LED, light emitting diode. Light emitting diode means it's a diode. If it is a diode, it has positive junction and negative junction. If someone applies voltage that would be more than its a kind of threshold voltage of a diode, then it will start conducting the current and it will start glow. The equation for this is 25 milliampere current should flow through this. I have just folded one side, one leg of this, claiming that is negative. So one leg is folded, okay, and this is a LED. This is These are the two capacitors. One is 330 microfarad and one is 1000 microfarad. Okay, and this is a 3.7 volt lithium ion battery, and then there is a resistor attached to it, that is 330 ohm. Okay, what is the equation for this? The equation for this is 25 milliampere of the current should flow through this diode in order to blink, in order to glow it. So 3.7 volt, 3.7 volt equal to current into resistance. So if current is 25 milliampere, 3.7 volt by 25 milliampere is the resistance that I have to take. 3.7 volt by 25 milliampere will go as 3.7 into 1000 by 25. 1000 by 25 become 40. 3.7 into 40. How much it will come? It will be around 150 ohm. 3.7 into 40. 7, 4. 28, 8, 14. Around 148. 148 ohm resistance is required. Anyway, I have taken 330 ohm of resistance. Someone can find resistance through the color code also. If it is visible, the color code of this resistance, then it is orange, orange and brown. So it will be 330 ohm, I believe. Okay, BB Roy, Great Britain, very good wife. So someone can find out the resistance of the anyway. Now the idea is I want to show that if this is a resistor and if I apply LED, then it should glow and it should keep glowing. That is the concept. So I'm applying the positive side, I'll connect and it should keep glowing. Hop, 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 hop. Okay, I believe this is visible. So this is LED, this is LED, and I'm touching now. Hope I believe it is visible. It is glowing, not glowing, glowing, not glowing. Okay, I can keep one kind of a curtain or something so that it will be dark. Okay, this is the best curtain. Okay, okay, so I'll try again. I believe it is darker now. Okay, this is LED and I'm placing now. Okay, so it is glowing. So LED is glowing, coming away, glowing. Okay, so if someone watches this, then this is a pure resistance circuit. It is a pure resistance circuit. Okay, if it is a resistance circuit, now the circuit diagram is that there is a 3.7 volt battery is there and there is a resistor and I am connecting LED in series. Okay, now it is something like some 12 milliampere current is flowing through it and it is glowing. It is glowing in one go only. If someone watches this, it is glowing in one go only. So if I connect again, it will just glow in one. I touch it and it will glow. Okay, I cannot make it even darker. Okay, I believe I made it much enough dark. Okay, so it's like a theater theater room now. Anyway, I'll try it again. So it should glow. Okay, this is what I can show. Okay, this is glowing. Okay, it is glowing in a way that it is constant glow. It is a constant glow. It is a constant glow. This is the concept of resistance. That if I apply resistance, immediately current flow and the strength of the glow would not vary. Okay, that is the idea. If I connect, then the strength of the glow will be will be constant. It will not increase or decrease. It will grow in a go only. It is not increasing and decreasing. It will keep on glowing. Okay. Now I am putting capacitor now. So capacitor, now both end of the capacitor I'll touch it. Both end of the capacitor I am touching it. So capacitor is completely discharged now. Capacitor is completely discharged. Now I'm going to put capacitor in series with resistor. So I'll just tie it. Okay, so Mr. Capacitor is tied now, positive end to the resistor. Now this is the circuit. Now there is a battery, there is a resistor, and there is a capacitor. Now other end of the capacitor, I am going to touch the LED. Just see LED how it is glowing. Okay, so idea is that negative part of the LED will be negative side of the battery and positive part of the LED. Now see how LED is glowing. At the beginning, LED would glow and slowly LED will go down. Okay, that is the concept. So now I am touching it. See, gone. Now, if I do it again, very little it is blinking, very little and gone. Now, LED, even if I'm touching it, now this capacitor is fully charged now. It will glow high light and slowly it will go away. Now this capacitor is fully charged now. Now I am applying this LED across the capacitor. Now this capacitor, I can take it out. Now this capacitor is behaving like a battery. Okay, now I'm going to put LED across this capacitor and let's see it is glowing or not. So positive end, positive end. Now negative end, I'll touch and see the LED. It blinked at the beginning and it discharged. Gone. Okay, I believe it is visible. Now there is no power in the capacitor. Okay, now I'll do it again. I'll try with other capacitor also. Okay, so capacitor is completely discharged. I'll touch it also. It is completely discharged now. And I'll try LED again. Oh, oh. LED will blink very high glow and slowly it will diminish. That is the concept. So I'm touching it. Hop, hop, gone. So this is called RC circuit. Resistance, capacitance. Hop. Okay. So battery. I had soldered it, but gone. Anyway. Okay. So I'll connect. Actually, I soldered it and the wire got broken. Anyway, I'll make it permanent. Okay. Resistance is now with the battery positive end. Now I will make this uh, kind of this tied this capacitor with the resistor. This is now RC circuit. Now this if this is RC circuit, now with the RC circuit I am going to put, now this is a battery, resistor and capacitor 1000 microfarad, and now I'll put a diode. Okay, and see how diode is blinking. At the beginning it will blink at very high speed. Slowly it will go down. See, it is blinking and gone. At the beginning, now this, now it nothing will happen. I'm touching it, it will not blink. Now this capacitor is completely charged. I'll put it across the capacitor. Okay, now I'm putting it across the capacitor only. Then it will glow and slowly, as per the capacitor power, it will go down. So I'm putting across the capacitor. This is capacitor. I'm putting across the capacitor. No battery is involved. See, at the beginning it blinked and then it is gone. Now this is completely discharged. Now, if I put it again with the battery, it will blink, it will glow, and then slowly it will diminish. Gone. So I can use other capacitor also. This is 330 microfarad. Okay. Now first I'll show that this capacitor. Okay, this is positive end, this is negative end of the capacitor. Now I'm going to touch LED across this capacitor, that is 330 microfarad. Okay, it is completely no blinking is there. This capacitor is completely discharged. Now I'll put capacitor across the resistor. So positive end will go on the positive side. Capacitor has polarity. Not all capacitor has polarity. Anyway, now it is a battery, resistor and capacitor. Now I'll put LED across it, positive, and since it is a diode, it is positive and negative. Now I'll put an LED will glow and slowly it will diminish. Oh, nothing is happening. Okay, I connected opposite way. Okay, so we have connected and now, okay, I had connected nicely. It is not working. Negative end will come there. So it was all right. I don't think it will work. If I place positive here, negative this side, will not work. Okay, it became very hot. Somehow there was a short circuit anyway. Or battery power is gone. I don't know. Anyway, I'll try again. So this is positive, this is negative, and LED should glow at the beginning and it will diminish slowly. See, it grew and now it is normal. Now, if I connect LED across the capacitor, it will glow in one go and slowly it will go away. Capacitor is fully charged. See, okay, little bit it did and it went away. I'll try again. It will now, I'm charging it. It will glow and it will diminish slowly. It grew and it went away. This is 2.330 microfarad. I believe it was better with the other capacitor. And battery is also discharged. It became hot in between. Okay, I'll try again with this capacitor. This was better performance. 1000 microfarad. Okay, so I'll try connecting. Now this is battery, this is resistor, this is capacitor, and the the LED would glow and slowly it will go fade away. Okay, nothing happened. Okay, I'll try it to discharge it. Oh, it was completely charged. Okay, now I'll connect again. Okay, it will blink and it will become faded. Blink, slowly, slowly, it went away. Now, if I put across the capacitor, now I'm putting across the capacitor, it will blink and it will go away. See, it blink, and now it is glowing little bit and it went away. Now, I connect it again with the battery, it will glow and it will go away. And it is going away. How much it is visible, I don't know. Okay, now I'll discharge the capacitor, I'll try again. I'm connecting both end of capacitor, capacitor discharge. Okay, now I'll try again. Now this is battery I'm putting, it will glow and slowly it will fade. Glowing, 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 gone. Okay, now I'll put across the capacitor now because capacitor is completely charged. See, actually it is a loose connection. Okay, now it is discharged. Okay, I believe it is all right. So fundamental is that if someone applies current across the RC circuit, then current start growing like, I'll try again. Now I'm putting across RC circuit and it will glow. At the beginning, glow will be very high, then it will diminish. Glowing and slowly gone. Now capacitor is fully charged. Now if I put across, I have to change the polarity now. Now if I put across capacitor, then it will glow and slowly it will go down because see, it is glowing and it is going down. I can see. Okay, so now there is nothing. Capacitor completely discharged. Now capacitor charging, now I am putting across the battery. Now it will glow at the beginning and it will fade. See, glowing and then slowly gone. Okay, so this is called RC circuit. Okay, this is called RC circuit. RC circuit means the whenever this is RC circuit. RC circuit battery and then resistor and then capacitor. If I connect this, if I connect this, then capacitor got charged. But at the beginning, flood of current will flow and then slowly current will choke. Okay, at the beginning, there is a high amount of current is flowing through the circuit. Okay, and at the end, now actually I have showed it already. If I put it across only across resistor, if I put only across the resistor, then this LED will keep glowing. It will never go off. If I only put this is resistor, if I put only across resistor, it will keep glowing. Always constant glow. See, but if I put it across, I'm short circuiting the uh, okay capacitor so that capacitor would discharge. Now, but if I put across capacitor, it will glow at the beginning and then it will go away. See, now it is glowing and slowly it went away. I'm discharging the capacitor. Capacitor discharge. I'll try it again. It will glow and slowly it will go away. Glow, glow, still glowing, gone. I'll discharge the capacitor. Now I'll place it again. Glow, slowly, 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 current gone. Means if you put across a resistor, then current is flowing at constant current is flowing. What is the current when you put only resistor across the battery? That is voltage by resistance is the current. There is no fluctuation. See, there we don't need calculus. There, the idea is we don't need calculus because it is constant. We said that calculus is used in algebra. Calculus is used in algebra where one is dependent and one is independent. If I put it across a resistor, then constant current is flowing through the resistor. And keep if this is x-axis is time and this is the current across the circuit resistor. If this is the time, this is the current, this is the origin where time is zero, then current is constant. If the height is current and this is x-axis is the time, at any time the current is constant. We don't need any calculus because both are independent to each other. The current that is flowing through the circuit and time. More time you take, same amount of current is flowing. Then if it is in that situation, we don't need calculus. But if you see the capacitor, if we add capacitor, then there is time at beginning, there is a kind of a high current is flowing. And then current is going down, 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 down. After at some time, current is zero. It is not glowing at all. This is called RC circuit. Battery, resistance, capacitance, and then battery back. Okay, now idea is can someone find the current time equation? At what time what current is flowing? Or voltage time equation, the across the resistance, how much is the voltage we are seeing? Or across the capacitance, how much voltage we are seeing? The current through the resistance and current through the capacitance, since they are in series to each other, the current that is flowing through them is same. Okay, this is a battery and this is the resistance and this is capacitance. The current is flowing same. Whereas voltage drop, there are three voltage drop. One voltage is the battery voltage 3.7 volt. One voltage drop is across the resistor and one voltage drop is across the capacitor. Okay, if I see this voltage drop, then across the capacitor, voltage at the beginning, voltage is zero and voltage is growing. At one time, the voltage across capacitor is same as the battery voltage, same. And then there is no current flow. In a circuit, if I have two battery and both battery polarization is same, current will not flow. Capacitor is behaving, capacitor is behaving like a battery at one time. Now idea is can someone find the voltage across capacitor as per the function of time? When time is zero, then there is no voltage across capacitor. It is behaving as R circuit, pure resistance. But as time is going away, then the current that is flowing through the capacitor is decreasing. At one moment, current will become zero and voltage across capacitor will come to a level that current will not flow. What is the fundamental of the calculus? Now, it forms in calculus because voltage across capacitor is dependent upon time and it is not whatever. It is linear, not linear, I don't care. Voltage across capacitor is dependent upon time. If I have entity like this, I have algebraic equation and in that one thing is dependent upon another, then we come to calculus. If it is multiplication, then it is integral calculus. If it is division, then it is differential calculus. Okay, very nice it is. Then how we can find? Now consider the voltage source is Vs. The voltage source is Vs. Okay. Now there is a I current is flowing through the circuit. I current will be same because it is in series. Then voltage will drop across the resistance is I into R. Consider the voltage drop across the capacitor is V. Now we have how many things we have taken? The voltage drop across the capacitor is V. voltage of the battery is Vs, and then the voltage across resistor is R into I, that is resistance and current at any time. Okay, now why voltage across resistor is R into I? Okay, the idea is if voltage is directly proportional to the current across the resistor. If I have a resistor, if I am calculating voltage across the resistor, okay, if resistance is constant, I increase the current, then voltage across resistance will grow. Means voltage is directly proportional to the current. Okay, now if I keep the current constant, current will not vary. And if I increase the resistance, then again voltage across resistance will grow. In that sense, voltage is directly proportional to resistance. Voltage is directly proportional to current. In that sense, voltage equal to current into resistance. Make sense? Now, let's see the capacitance. Capacitance has something called C, capacitance. It is not resistance, it is capacitance, another entity. If a capacitor has more capacitance, then it can store more energy. If capacitance is very less, it will store less energy. Means charge that is stored in the capacitor is less. If capacitance is very high, then it will store more energy. Anyway, now voltage across capacitor is directly proportional to the charge it has, provided capacitance is constant. Keep the capacitor keep the keep take same capacitor. If capacitor is same, then voltage across then capacitance is constant, same capacitor. Okay, now inside the plate of the capacitor, increase the charge. If someone is increasing the charge across the plate of capacitor, then voltage will grow. Means voltage is directly proportional to the charge it has. Okay, now keep the charge constant. The amount that there are two plates, cathode and anode. The charge that it is holding, keep the charge constant. Now keep increasing the capacitance. If you increase the capacitance and charge is constant, voltage will start decreasing. You keep the charge same and decrease the capacitance. The power of the capacitor decrease, keeping the same charge, voltage will start growing. Okay, that is the inherent nature of capacitor. Means voltage is inversely proportional to the capacitance. Voltage is directly proportional to charge. Voltage equal to charge by capacitance. Okay, so the idea here is voltage across capacitor V equal to Q by C, charge by C. Okay, if that is the case, then now what is the equation of this circuit, RC circuit? Vs, that is the battery source, voltage across the battery source, is now distributed among resistor and capacitor. Voltage across battery source equal to R into I, current at any moment, R into I plus Q by C, R into I plus Q by C. Okay, now what is I? What is I? Or I can say voltage Vs equal to R into I plus V. V is a voltage across capacitor at any time. What is I? Now if I see V across capacitor, V equal to Q by C. Now what is the current at any moment? Current is the charge by time. How much charge is stored in the capacitor divided by the time. In how much time charge is stored, that is called how much current is there. Per unit time, how much is the charge? But provided that relationship should be linear. Make sense? Voltage equal to charge by capacitance. Okay, the current that is flowing through capacitor is charge by time. How much charge the capacitor has stored divided by in how many seconds. That is the current. If time is less and current and charge is high, then high current would flow. If time is very high and charge is less, less current is flowing. But unfortunately, the relationship between charge and time is not linear. Division of q by t is not linear. If it is not linear, then Certainly, the charge storage is dependent upon the time. Time is independent and time is denominator and charge is Q is numerator. Numerator is dependent upon denominator and it is not linear. The division is not constant. In that sense, we will go by calculus. So, voltage equal to Q by charge, Q by capacitance. Current equal to Q by T. Current equal to dq by dt. This is better because charge by time is not linear. It is variable and charge is dependent and time is independent and independent is denominator. So current equal to dq by dt. Now we have V equal to Q by C. dV by dt equal to 1 by C dq by dt. Current equal to dV by dt equal to 1 by C current. Current equal to C into dV by dt. Okay, now again we'll come back to this RC circuit. Now in this RC circuit, battery, resistance and capacitance, they are connected in series. I connected it. They are connected in the series. Now battery is Vs. The voltage across resistor is I into R and voltage across capacitor is V. I have to find V in the variation of time. In that is, if that is the case, then the Vs, this Vs equal to I into R plus V. I equal to C dV by dt where V is voltage across capacitor. Current is same across capacitor and resistor. So Vs equal to CR dV by dt plus V. Okay, if that is the scenario, then how we can solve it? Then it becomes RC dV by dt equal to Vs minus V. Okay, if that is the scenario, then dV by Vs minus V equal to I'm sorry, dV by dt by Vs minus V equal to R into C. Hope. I'll try again. Okay, what we got here is that Vs equal to R into C dV by dt plus V. R into C dV by dt equal to Vs minus V. dV by dt y Vs minus V equal to 1 by Rc or dV by Vs minus V equal to dt by Rc. Okay, now we have 1 by Vs minus V into dV equal to 1 by Rc into dt. Now we can do integration of both now, where time will be 0 to any time, whatever it is. Let's calculate the integration. Now we have dV by Vs minus V equal to dt by R into C. Okay, if I do integration of this to get to settle down the dV and dt, 1 by Vs minus V. Let's say Vs minus V equal to X. Vs minus V equal to X. Vs is constant, that is the battery voltage. In that sense, minus dV equal to dx or dV equal to minus dx. Let's settle it down. Now it is dx minus dx by x minus dx by x. Okay, integration from lower limit to higher limit. Okay, in that scenario, minus dx by x, minus I can keep outside, dx by x. Now this integration will be ln, 1 by x integration is ln, natural log, ln x. X, I can replace it back with the Vs minus V. Ln Vs minus V, minus is outside. Minus I can settle down on right side. Right side it is dt by Rc. Integration become t by Rc minus t by Rc minus t by Rc. This side ln Vs minus V. Now if you see the limit at the beginning, ln we were integrating dV voltage across the capacitor. At the beginning, voltage across capacitor was 0. Voltage across capacitor was 0. At the end, voltage across capacitor is V, any V. Okay, from 0 to any v. This is what we are trying to find out. In that sense, ln Vs minus the top is Vs minus V minus ln Vs. ln Vs minus V minus ln Vs. That will come at ln Vs minus V by V. ln Vs minus V by V. ln will go on that side and it will become exponential. Now Vs minus V by V, okay, equal to exponential of minus t by Rc. Now it will become Vs by V minus 1. Okay, if that is the case, then now someone can settle it down. Minus 1 will go and it will become plus on that side. 1 plus e to the power minus t by Rc equal to Vs by V. V, okay, that is the scenario. Then V, what would be Vs? What would be Vs by V? V would go this side, then V would be Vs, something like that. Someone can try. This is how we calculate the Vs anyway, or okay, I'll try it again. Anyway, we have minus dx by x when x equal to Vs minus V. Okay, that is ln x. Now let's see the limit x, lower limit to higher limit. Now Vs minus V equal to x. Okay, when V is at the beginning, V is 0. In that sense, x is Vs. So limit is Vs. At any moment, it is V. So Vs to V. At any moment, it is x equal to Vs minus V. At any moment, the V is V. Vs to Vs minus V. ln x. Okay, same thing came. ln Vs minus V minus L minus ln V minus ln Vs. Okay, that is the mistake we were doing. At the beginning, V is 0. So x equal to Vs. Lower limit is Vs and higher limit is Vs minus V. That is true. Now it is ln. Minus is this side. Minus will go that side and it becomes minus t by Rc. Now here it is ln Vs minus V by Vs. Now it becomes 1 minus Vs by V by Vs. Vs minus V by Vs. Vs minus V by Vs. Okay, equal to e to the power minus t by Rc. Vs I can keep that side. It becomes Vs minus V equal to Vs e to the power minus t by Rc. Now V I can keep this side and V push this side. It becomes Vs 1 minus e to the power minus t by Rc equal to V. That is the voltage across the capacitor. Voltage across capacitor equal to Vs, that is the voltage source 3.7 volt, and in big bracket 1 minus e to the power minus t by Rc. Now t someone can take. If t is 0, time is 0, then e to the power minus t by Rc, e to the power 0. E to the power 0 means 1. 1 minus 1, 0. Means voltage across capacitor is indeed 0. Okay, now V equal to Vs and in braces 1 minus e to the power minus t by Rc. When t equal to Rc, that is also called tau, time constant, then it becomes e to the power minus 1. Okay, that will 1 by e to 1 by e. I believe e value is 3 point something, whatever. That much is at time constant, that much is the voltage. If time is infinite, e to the power minus infinite, that is 0, then V equal to Vs. Okay, that is the fundamental to get the voltage across the any moment. Voltage across the capacitor at any moment is Vs, that is a voltage source in bracket 1 minus e to the power t by Rc. Okay, what about current? This was the fundamental of the current. I believe I'll calculate in the next session. I'm really tired. Okay, so I'll try showing it again. I don't know. Now it is very bright. So I'll first diffuse this capacitor. Now capacitor both end I am connecting and capacitor is diffused completely. Okay, if I put LED across the capacitor, then it will, okay, if I put LED, this is negative. If I put LED across the capacitor, LED will not glow. Nothing is glowing. Now I'll put everything. Now this is a full circuit, and now I'll make it, I'll touch it, and LED should start glowing, and slowly it will come down. Glowing, 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 gone. Okay, now LED is gone. Okay, I'll diffuse the capacitor again. I'm diffusing the capacitor. Capacitor is gone. I'll try again. Hope, hope. LED will glow and slowly it will. Okay, I should have soldered it everything. Anyway, I'll try it again. Now LED will glow and slowly it will diminish. Glowing, slowly it is gone. If I put LED across resistor only, see it is, if I put LED across resistor only, no capacitor is involved, it will grow always, always. It is visible. It will grow always. But if I put, now I'm discharging this capacitor. Now if I put LED across the capacitor full, it will grow and it will come down. Glowing, slowly it is gone. Now capacitor is fully charged. If I keep it across the capacitor, I disconnect it, capacitor is fully charged. Now Mr. Capacitor is fully charged. If I is positive, now if I touch it, it will grow and it will go down. It will touch, it will glow, and it went off. Okay, so capacitor discharge very quickly. Okay, only capacitor is discharge very quickly. In RC circuit, capacitor will discharge slowly. That also I can show. Okay, it is in my hand. I can enjoy it the way I want. So when I connect it directly across the capacitor, then it discharge quickly. Anyway, I'll charge it again and discharge it through the capacitor. So I'm charging it full circuit. It will glow and it will glowing, and slowly it is still glowing. It went off. Now I'll discharge it through RC circuit, not directly. Now I'm discharging the capacitor through RC circuit. So this is R. Slowly it will go off. Okay, it's blinking. I don't know. It is blinking and then still power is there in capacitor. See, little bit is there. If I charge it again and try to discharge it, glowing, and slowly it went off. Now I'll discharge it through the RC circuit one, not through the, only through capacitor. Okay, it blinked. See, it is blinking slowly, it will go off. So if I discharge through RC circuit, then it will discharge slowly. If I discharge directly this LED through the capacitor, it will quickly it will go off. Anyway, all fundamental we will see. Anyway, we found out that calculus is important here when we have dependent and independent, and division is converted into differentiation, and multiplication will converted into integration. Now we have voltage across capacitor equal to Vs, that is the voltage source, bracket 1 minus e to the power minus t by Rc. For God's sake, it is impossible that anyone can deduce this formula without calculus. Anyway, we will see in the future session that how discharge circuit and current and other things, the equation will work through. Please don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.